Oftentimes, as we're learning about science, we forget to explore the idea of why are we learning this stuff? Instead of just learning it for the sake of learning, there are applications. And one of those, when we're learning about electrons and learning about light, is the photoelectric effect. And here's the thing, the photoelectric effect explains how solar panels work or how solar cells work. And what we've been exploring is how electrons give off light. But there's more to that story. So we're all familiar with solar panels, and the idea is that the sun's light comes in, it hits the solar panels, and then something magical happens. Well, it's not magical, it's science, it's chemistry, and it's physics, and it's what we've been learning about if you've been following along on all of these lessons. It's called the photoelectric effect. Now let's break this up. The electric part refers to electrons and eventually electricity. Those are both related because the movement of electrons is what causes an electrical field or electricity. Photo refers to light. So it's electricity coming from light. And we know that because we know if you put a solar panel out, you're going to get some electricity. But why is that? We've been going through in all these lessons, and I've been using the ladder as my example. Now, what the ladder means is that as an electron gets further away from the nucleus, just like if you were to climb up a ladder, and if you were to fall from the top of the ladder towards the ground, that would release a lot of energy. It would hurt. Now, electrons, they can climb the energy level ladder as well. In other words, they can get further away from the nucleus. And if they fall back to their ground state when they're further away, that's giving off more energy. And this is what we've been exploring with light for the past several lessons. If you're unfamiliar with that, there's links down there in the description that'll take you back so you can get caught up to where we're at. What happens when an electron absorbs energy or absorbs other light? As this electron absorbs light, it will move up to a higher energy level and then fall back down to its ground state. When it falls back down, it gives off light. Now, the analogy here with the ladder is that if we gain some energy, we'd climb higher up on the ladder and then we would go back to our ground state. Electron does the same thing. How much does it jump up? Well, that depends on how much energy it absorbs. Well, what if it absorbs enough energy that it jumps way up into the, so far away from the nucleus that the positive nucleus can't pull it back down to its ground state? Well, then that electron has escaped the atom. And that electron might go flying off and be transferred to another atom, and that one being transferred to, and if this transfer continues to happen, that's the definition of electricity. So let's take this back to the photoelectric effect. Just enough light in this room to be able to get it to work, which is pretty amazing. I've got another picture of it down there. We have on our solar array or our solar panel, we have a mixture of metals in there, okay? And when light comes in and hits those metals, it causes the electrons to get excited. Those electrons will jump up to a higher energy level and fall back down. Now, let's say the energy in the room that you're in or you're outside is enough energy, and scientists have chosen a very specific combination of metals down here whose electrons can very easily jump up quite high if they absorb a small amount of energy. And so the sun comes in, the rays or even the light from this room, and it hits electrons. They may jump up high enough that they escape the atom. When they do, they go flying off into space. Now, if we give them somewhere to go, and those electrons get continually passed from atom to atom to atom, like through a metal wire, that is the definition of electricity. So this is a very simple look at how electrons and light or energy that hits those electrons can cause electricity or an electrical current. Now, that's a quick sidestep because what we've looked at up to this point is light as a wave. We've looked at the electromagnetic spectrum and all the waves involved. We've looked at light as a photon, as a particle. And now we just looked at, okay, when we put all those things together, like the energy from light coming in and hitting metal and hitting those electrons and causing the electrons to move on down the line, we've just made electricity. So we need to boil this down even one step further to fully understand electrons and to fully understand light and to fully understand an atom into the quantum mechanical world. This is where it starts to get kind of weird, and that's going to be the next lesson. I'm proud of you for sticking with me as we learn all these things. There's lots of stuff popping up that you can click on and learn even more. There's stuff down in the description. Hit the subscribe button or go over to bealscience.com and watch some crazy experiments and explosions and things going on over there. And I do all of this to convince you to keep on learning.